Good day, sir. This is a video simulation for assignment 1, which is the AC to DC rectifier circuit. My name is Ng Yan Wen, together with my teammate Derek and Nabil. In this circuit, we are using an input AC voltage of 150 volt RMS with 50 Hz. It is then passed through a transformer with 10:1 ratio, primary to secondary. The input voltage is then rectified using a bridge rectifier which consists of 4 diodes. Each diode has a knee voltage of 1 volt in this simulation. The usage of bridge rectifier is to convert AC waveform into pulsing DC waveform at the output. A capacitor with 470 millifarad is used as a filter to smooth the output waveform from a pulsing DC into a smooth DC output. A 1 k ohm resistor is used as a voltage divider, and the other resistor is 1 k ohm is connected parallel with the Zener diode with a Zener voltage of 6.8 volt. 4 oscilloscope is used to measure the waveform. The first oscilloscope with 2 channels is used to measure the voltage waveform before and after the transformer. The second 2-channel oscilloscope is connected at the rectification junction. The third 2-channel oscilloscope is connected between the resistor R2 and R2 with respect to ground. The fourth 2-channel oscilloscope is connected at the Zener diode and the resistor R1, which act as the load in this circuit. After running the simulation for 5 seconds, this is the result of the waveform of the first 2-channel oscilloscope. In this waveform, the blue color waveform is the waveform before the transformer, and the red color waveform is the waveform after the transformer. At the marker point, the peak voltage of the blue color waveform reaches 211.345 volt, and the peak voltage of the red color waveform is 21.1345 volt. This proves that the voltage has been stepped down. The peak voltage of the input AC supply is 211.345 volt is because the input voltage is 150 volt RMS. The value needs to be multiplied with Z2 to get the peak voltage. This is the result of the second oscilloscope. The purple color is the waveform for the positive cycle of input, and the red color is the waveform after the voltage has been rectified and filtered. The observation shows that the purple waveform is still a sinusoidal wave, which has not passed through the bridge rectifier yet. The red color waveform has almost reached a steady straight line, which proves that the input has been rectified and filtered by the capacitor. The result of the peak voltage of the purple waveform is slightly higher than the red waveform is due to the knee voltage of each diode is 1 volt. After rectification, the initial voltage 20.8 volt is subtracted with 2 volt, so the simulation result shows a value of 19.02 volt, which is approximately matches the theoretical result. This is the result of waveform at the output. We have combined the measurement get from the third and fourth oscilloscope. The red color waveform is measuring Zener voltage. Blue color waveform is measuring voltage R1, which is the load of this circuit. Purple color waveform is used to measure voltage R2, and the gray waveform is measuring the total output voltage. In this simulation, the Zener diode is in an on stage, which it will regulate the voltage of resistor R1. So in this simulation, the observation shows that the voltage of Zener is equal to the voltage of R1. This is the manual calculation for the circuit analysis where we compare the simulation result by using theoretical calculation. To determine the V peak, we multiply the VRMS with Z2. We can get a result approximately same with the simulation result. Then we calculate the secondary output of the transformer using ratio of turn and voltage. By dividing the initial V peak with 10, we got a voltage value of 21.2135 volt, but the simulation result is 21.1345 volt. Then we calculate the voltage after rectification of the bridge rectifier using KVL. We got a result of 19.2135 volt, assuming the knee voltage of the diodes in the simulation is 1 volt. The simulation result shows 19.0273 volts. After that, we determine the working condition of the xenon diode using voltage divider rule. We can calculate that the voltage of R1 is higher than the xenon voltage, in which R1 is connected parallel with the xenon diode. So the xenon diode is in on condition. It will regulate the voltage of R1 and the voltage of R1 is the same as the xenon voltage. This achieves a stable voltage output at the load, in this case R1. Finally, we can calculate the voltage of R2 using KVL to get a result of 12.4135 volt, which is almost same as the simulation result. To conclude, the result of simulation is approximately same as the result that we calculate manually. This proves that the technique that we apply is correct.